Now that we've learned about matrix equations, we can use this concept to help us solve other types of equations that may be a little bit more time consuming through algebraic methods. So you can see here that we've learned three methods of solving a system of equations. First, we can graph and visually get the solution, which is more than most of the time a point of intersection. We can also use the substitution process and the linear combination process, and sometimes the linear combination process is known as elimination or the addition method. In addition to this, we can use the inverse matrix and a matrix equation to help us solve systems of equations. And so the first skill that we've got to learn is we've got to learn how to convert from a system of linear equations to a matrix equation. And so if you know how to multiply matrices by hand, this actually makes more sense as to the reason why these two work. But from just a simple breaking things apart kind of standpoint, we want to make basically a matrix A, a variable matrix X, and have them equal to a matrix B. So this is pretty straightforward. If we look at this linear equation and we take each of the coefficients, the 5, the 4, the 1, and the 2, when we make a matrix out of them, we can make that a matrix A. Then if we take the two variables, X and Y, and put them in their own matrix and stack them, we can say that that is the variable matrix X. And then of course what we're equaling to, we can make the matrix B. Now we learned in the previous video that this equation ends up equaling the inverse of matrix A times matrix B. And so once we've converted a system of linear equations to a matrix equation, then we have a method of actually solving the matrix equation already. And so that makes solving the system of equations much easier. So let's just take a look at this first example. Here, sample problem number 1, and all we ask you to do in part A and B is convert from a system of linear equations to a matrix equation, and then vice versa on part B. So go ahead and take a minute to do those two parts. For part A, we're going to convert this to a matrix equation by starting with the coefficient matrix. So I'm going to say negative 3 and 2, and then 4 and negative 1. That makes the coefficient matrix. Now I need the variable matrix, which is just simply the X and the Y stacked on top of each other. And it's going to equal to the constant matrix. And so there is our matrix equation. And then we could solve that based off of our previous lesson. Now if I want to reverse this process for part B, we're going to take each part of the top part of matrix A, the first matrix, and what I'm going to do is I'm going to take each of these coefficients, and the first one is going to be matched up with the X, and the second one is going to be matched up with the Y. And that's actually how we multiply matrices. We multiply the first row by the first column, and so we're going to do 2 times the X and negative 1 times the Y. The same thing would happen on the bottom. We would have the negative 4, the 9, and the 1, and then the first one would take the X and the second one would take the Y, and of course this is a plus. And so that would be our system of linear equations from a matrix equation. Okay, we're just going to stop right there, and in the next video we're going to actually take a look at a couple examples of how to work this.